Hi, my name is Marty Burke, and I'm excited to tell you about Blocc Chemistry, a new way to build molecules that is friendly to robots, AI, and anyone, including you. We humans have been making big tools for millions of years. About 200 years ago, it first became possible for us to also make very small tools by linking carbon atoms to form molecules. These molecular tools can do lots of important things, like act as medicines and materials, fertilizers, and many different types of consumer products. Until recently, the process of making such molecules required specialized training and equipment, and this created a big challenge. There are now 8 billion of us on the planet, representing 8 billion imaginations, our greatest natural resource. And yet, until recently, those of us who can go into a lab and make molecules using our hands, we all fit in one building. That means 99.9999% of all of our imaginations can't contribute. And that's not good. Blocc Chemistry is a new way to iteratively form carbon-carbon bonds that shatters this barrier. It's spelled with a double C as a wink to those carbon-carbon bonds that lie at its core. Here's how it works. We start with building blocks that have been prefabricated to enable their simple iterative assembly. They specifically contain pieces called boronic acids that have a built-in switch for controlling the reactivity of carbon atoms. A first generation of this switch was called N-methylamino-diacetic acid, or MIDA for short, and a recently discovered second generation that's about 1,000 times more effective is called TIDA, and this switch allows the blocks to be precisely assembled into new molecules. The second key piece is that the MIDA and TIDA boronates stick to a material called silica gel and then unstick under different conditions. And this discovery made it possible to easily purify the molecules while they're being made. So these two features together make Blocc Chemistry very friendly to robots. It turns out the standardized and modular nature of Blocc Chemistry also makes it friendly to AI. Kind of like ChatGPT tokenizes language into words, we found we could tokenize molecules into blocks and create a new language for chemistry that directly connects the digital and physical worlds at the molecular scale. And because Blocc Chemistry is friendly to both robots and AI, it's friendly to anyone. This opens the door for non-specialists to predict and create small molecule tools to solve problems that they personally care about. It also opens the door to a new way of teaching chemistry by engaging in its discovery. We've already built a curriculum around Blocc Chemistry that's reached more than 10,000 students, from grade school all the way through graduate school. Google hosted a Kaggle competition built on our Blocc Chemistry data, inviting expert and amateur computer scientists from around the world to help predict what a newly discovered molecule can do. We also built a digital molecule maker, so anyone can design a molecule on screen and have it built for real, 3D printed by a synthesis robot. A high school student in Chicago even built a Minecraft for molecules, where you construct a molecule block by block inside a video game and print it directly from there. This platform was leveraged by middle and elementary school students from across the globe. Many challenges remain before Blocc Chemistry reaches its full potential. But increasingly, the question that matters most is this: what molecular tool will you build?